A full adder is a logic circuit which performs addition of three numbers. It has three inputs, A1, B1, and C1 for addition, and two outputs, S1 and C2. Input A1 and B1 are single-bit binary numbers. C1 comes from the addition of the previous digit. The new sum S1 and carry C2 are calculated from the addition of A1, B1, and C1. Here is the truth table for the full adder. At the calculation, the sum 1 becomes 1 whenever exactly one input A1, B1, or C1 is 1. The sum 1 becomes 0 whenever exactly one input A1, B1, or C1 is 0. At the first row, there are all zeros, and at the final row, there are all ones. First, verification of the full adder. First, all three inputs are zeros. Reset all three clocks. A1 equals 0, B1 equals 0, and C1 equals 0. Both AND and XOR gate do not forward the first clock pulse. The second clock pulse do nothing. The second XOR gate do not forward the third clock pulse. The result is the sum and the carry stay at 0. Next, reset the clock 3, clock 2, and clock 1. Input A1 equals 0. Input B1 equals 0. Both AND and XOR gate do not forward the first clock pulse, and C1 set to 1. This input is forwarded to the second XOR gate, but it's not forwarded to the output of carry 2. Carry 2 stays at 0. Next, activate the second clock. The clock pulse is not forwarded to the output or carry 2 and to the second XOR gate. Next, activate the third clock. The second XOR gate forwarded the third clock pulse. The result is C2 equals 0 and S1 equals 1. Next, reset the clock 3, clock 2, and C1, and clock 1. Input A1 equals 0. Input B1 equals 1. Act the first clock. The clock pulse is not forwarded to the AND gate, but it activates the first XOR gate and two switching pins. Now, input C1 equals 0. Next, activate the second clock. The clock pulse is not forwarded to the output of carry 2, but it activates the input of the second XOR gate. Activate the third clock. The second XOR gate forwarded the third clock pulse. The result is C1 equals 0 and S1 equals 1. Next, reset the clock 3, the clock 2, carry 1, and clock 1. Input A1 equals 1. Input B1 equals 0. Activate the first clock. This clock pulse is not forwarded to the AND gate, but it activates the first XOR gate and 2 switching pins. Now, input C1 equals 0. Next, activate the second clock. The clock pulse is not forwarded to the output of carry 2, but it activates the input of the second XOR gate. Next, activate the third clock. The second XOR gate forwarded the third clock pulse. The result is C2 equals 0 and S1 equals 1. Reset. The clock 3, clock 2, carry 1, and clock 1. Input A1 equals 0, B1 equals 1. Activate the first clock. This clock pulse is not forwarded to the AND gate, but it activates the first XOR gate and 2 switching pins. Now, input C1 is set to 1. This pulse is forwarded to the output of carry 2 and to the input of the second XOR gate. And it also activates the second clock. The clock pulse is forwarded to the input of the second XOR gate. Next, activate the third clock. The second XOR gate do not forward the third clock pulse. The result is C2 equals 1 and S1 equals 0. Next, reset the clock pulse 3, the clock 2, carry 1, and clock 1. Input A1 equals 1, B1 equals 0. Activate the first clock. This clock pulse is not forwarded to the AND gate, but it activates the first XOR gate and 2 switching pins. Now, input C1 is set to 1. This pulse is forwarded to the output of C2 and to the input of the second XOR gate. And it also activates the second clock. The clock pulse is forwarded to the input of the second XOR gate. Next, activate the third clock. The second XOR gate do not forward the third clock pulse. The result is C2 equals 1 and S1 equals 0. Reset the clock 3, clock 2, carry 1, and clock 1. Input A1 equals 1, B1 equals 1. Activate the first clock. This clock pulse is forwarded to the AND gate, but it does not activate the first XOR gate and 2 switching pins. Now, input C1 is set to 0 and activate the second clock. This pulse is forwarded to the output of carry 2. Next, activate the third clock. The second XOR gate do not forward the third clock pulse. The result is C2 equals 1 and S1 equals 0. Finally, reset the clock 3, the clock 2, carry 1, and clock 1. Input A1 equals 1, B1 equals 1. Activate the first clock. This clock pulse is forwarded to the AND gate, but is not forwarded to the first XOR gate and two switching pins. Now, input C1 is set to 1. This pulse is forwarded to the input of the second XOR gate and activates the second clock. This pulse is forwarded to the output of carry 2. Next, activate the third clock. The second XOR gate forwards the third clock pulse. The result is C2 equals 1 and S1 equals 1. So this full adder works correctly. Mechanisms of the full adder. It has two XOR gates, AND gates, three equal gates, and three clocks. It consists of these parts. Three inputs, A1, B1, and C1. Two outputs, C2 and S1. Two coupling plates for XOR gate, and a coupling plate for AND. And three clocks, clock 1, clock 2, and clock 3. These three parts are links. This is the frame. This is clock 3. This is output S1 with switching pins. This plate is an output of AND gate. This plate is an output of the first XOR gate and clock 1. This plate is an output for C1. This is a link from the first XOR gate to the second XOR gate. This equal gate can transfer the vertical movement to the horizontal direction. This is the clock 2 plate. This is an input of C1. This carry 2 plate works as a OR gate. Then the input C1 is forwarded to the OR gate and second XOR gate. These are input plates for A1 and input B1. Finally, these are coupling plate for AND gate and two XOR gates. These spacers are inserted between coupling plates of XOR gates to reduce the friction. And we completed building the full adder.